On this episode of On the Bridge, we are going to explore a much debated and potentially transformative idea in superyachts, nuclear propulsion. Not theory, but real discussions about whether nuclear could power the next generation of yachts and what that means for owners, builders, and the wider industry. I'm joined by Derek Munro from NOxFree, Ben Geary from Döhle Yacht Management, and Jez Sims from Lloyd's Register. This is part one of a two-part podcast. Welcome. Thank you so much for joining me, Jez, Ben, and Derek. So I'm going to crack on with the questions because this is an interesting subject that I'm intrigued to know more about from three experts. So Derek, let's start with you. Where did the NOxFree journey begin and what problem are you trying to solve in yachting?
Yeah, so it started in June 21 when a client approached me to see about putting nuclear onto yachts. And the purpose of it was that if he could prove to the public that he was a multi-billionaire happily sitting on his yacht with a nuclear-powered vessel, obviously that then it would be safe for public use on land.
Sure.
He ultimately wants nuclear to be the main power source on land to clean up the planet. So we had a long conversation on the phone. I figured out that, yes, I wanted to be involved in the project. And I said, look, we'll put together a feasibility study for you and we'll present it to you at the Monaco Boat Show. So we put together a 287-page feasibility study. And he asked me to keep it very confidential. So I brought in two friends who I knew were really into the nuclear package and a designer. So Dave Lewis from Laurent Giles is part of the NOxFree team. And so is Steve Rasmussen from Rasmussen Marine. And so, like I said, we created this 287-page feasibility study, gave it to him. He went away and read it. 6 weeks later, came back, said, right, let's proceed and develop a project, see how we can make it work, and how we can integrate it into the vessel and the effects it would have on the vessel. We then went out and we traveled around and we visited a few manufacturers, and we looked at how at that time we would put a nuclear module into a boat. And at the time, the smallest we could kind of find was 15 to 18 megawatts, which is actually really large. So it meant that the boat had to be 120 meters plus in size. And so we went down this development track and created a GA, did all 3D modeling, visited a few shipyards, got everyone involved. And then the client decided in 24 that he wanted to put a bit of a pause on things. And at that point, because we'd invested so much time in it and we believed in it, we as NOxFree decided that we would continue. Engel de Boer from Lloyd's, who we'd obviously worked together at that stage for about 3 years, and he said, look, I think I've got a product that you might be interested in. So he introduced me to the owner of Deployable Energy, and Bobby and I had a good long chat. And then we said, right, let's move this into the yacht and marine segment. And their unit is the 1 megawatt deployable energy, what we call the Unity module.
Right.
And the idea, obvious, is to reduce fossil fuel use, get rid of boats using fossil fuels as much as possible.
So what is the Unity model then in simple terms?
In simple terms, it is a 1 megawatt module. It's 2.8 meters in diameter, just under 3 meters in length, fully loaded with all the shielding and everything. It's 45 tons in weight. It can fit anywhere into a boat. We believe it'll fit into anything over 40 meters, depending obviously on the regulations and what's required on top of that shielding, if anything.
Yeah.
Ideally, there'll be nothing extra required, in which case you just slot it in kind of like a generator. In which case there's no fuel tanks, no diesel on board at all, and everything becomes electric.
So that's my next sort of question. Why nuclear then, rather than hydrogen or batteries or?
We believe that, well, it'll be a combination of two things, in our opinion. We'll be putting nuclear with batteries onto boats.
Right.
And there's a reason for that, and that is that if you power down a nuclear unit, when all these new micro reactors will be able to be powered down and powered up. So if you powered down because you're at anchor and you're only using, let's say, 20% load because the crew is on board, if you needed to move in an emergency, it's like having an emergency generator on a boat. You'd use your batteries to get your anchor up, to get everything going whilst the nuclear unit safely ramps up.
Right.
And that doesn't take long. That's, it's minutes. But at the same time, as any captain or engineer knows, if you need to move, you need to move now.
Yeah, sort
So-
of an instant.
So the batteries are there
resource.
to balance that out. And also, if you set your boat up correctly in the future, you'll probably find that if you install the batteries and the right amount of Unity modules, that you'll increase the life expectancy of this Unity module because you're using your batteries a bit more.
Yeah,
So otherwise, if you relied on the Unity module, your life's going to be maybe 10, 12 years,
right.
maybe a little bit more with yacht usage. But by using the batteries as well, you could extend that out to 20, 25, 30 years, depending on the battery pack. We see it being a combination of the two. And by doing that, by 2030, assuming all the testing that's happening right now proceeds well, we should see boats over 40 meters, zero fossil fuels. That's the hope.
Yeah, it doesn't seem that far away, 2030.
It's one build cycle away.
Yeah.
For a big boat. That's one of the reasons we're discussing it all now.
Yeah, so Ben, okay, there's so much to unpack there. I'm so interested, but let's sort of go back to that. So Ben, what made you get involved in the discussions of nuclear? And from an owner and operational perspective, what are your thoughts on the comparison to alternatives?
I think the reason I'm involved is it's an exciting time in yachting. Okay, so we've got a number of young guys coming into our industry, into our company, and it's a really cool time. When we all grew up, because we're all old and grey, it was
all of us.
kind of twin shafts, twin engines, and it was kind of a basic system.
Yeah.
And now you look at technology that's coming, and it's changing all the time and rapidly. Like we talked about nuclear, and Derek's been talking about it for a while, and so has Lloyd. But really, in the last 18 months, has it kind of come into the forefront in yachting? And I think what's exciting, like what Derek started with, is it takes an owner to go, I want to show the world that this happens. We've seen it with like the liquid hydrogen boats and others. You need one person who is generally very wealthy,
Of course.
to kind of prove that this technology is working, that it's fundamental, will improve what we're doing. And, we are all in yachting because we love it.
Yeah.
And it's a time where, yachting is being the Formula One of the maritime world, which for a long time people have pretended it is. But actually, I think reality now is with the technologies, with the green technologies coming, they are pushing it, and yards are pushing it, designers are pushing it. And so I'm excited by it because, as Derek said, what will happen in maritime, and Jez will say the same thing, is there'll be multiple fuels depending on where you're going, what you're doing. And this benefits the yachting world because, as Derek said, the lifespan potentially 15 to 25 years, you never have to bunker fuel.
Yeah.
Ever. And if you can fit it on a 40 meter, when I grew up in yachting, that was the size of boats we were producing. You can go back to high speed yachts. You're not trying to be economic on fuel, but you're green. You are pushing out green energy, and you can go fast. You can go forever without having to bunker fuel, which makes a massive difference and to the experience of yachting.
Sure. Yeah.
Your
for
maintenance
the
costs
owner.
also drop
Yeah.
significantly, with not only the fact that you don't have to buy fuel for your boat, but the maintenance of the engines and everything that goes with it, the exhaust systems, the flaps for firefighting, all that stuff just drops away significantly.
Yeah.
And even space. So the interior designers will get very excited because suddenly you'll have more space. You haven't got the fuel tanks. You may have smaller engine rooms. The space that becomes available as well, which in yachting, as anyone will tell you, whether you've got a 30 meter boat or 140 meter boat, space is a premium.
Yeah.
It all benefits what we're trying to achieve.
Yeah.
And those huge ducts going from the engine room up to the mast. You always walk into a saloon on a boat, and in the middle, you got these windows, then this thing that pops out, and then more windows. That's all ducting.
Yeah.
You get rid of all that, you can have windows all the way along, so much space regained for better purposes.
Yeah. Going back to what you were saying, 100% agree. Right now it feels exciting, as in the technologies, the designs that are coming out. It feels also as if owners are getting excited to try new things. You know, when you think back 20, 30 years, even building a boat with, I don't know, a different feature on was considered pushing the realms of design or technology, whereas now it feels like people are coming into the industry and building things that they want to. I mean, look at some of the boats that have come out in the last year. The design is not just a big white shiny gym palace, it's something different, and people are interested in investing in, look at Black Pearl, which we've talked about before. So it does feel as if there's an interest in pushing forward with technologies, but always when something is new, you always get people with lots of questions and saying it won't work. And so, Derek, going back to what you're saying about the design then, so what would this mean for a boat in design and then being built to carry this technology?
Practically, you will gain a lot of space inside the vessel. Just like I said, from the ducting and everything else, we've calculated out with our 3D drawings we've done for a couple of potential clients that as the boat gets bigger, you potentially regain a whole deck
Really?
of space for the
Yeah.
crew, you know, whether it's for storage or for putting your HVAC. Having said that, you know, these units create 1 megawatt of electricity, but they create 2 megawatts of thermal power. And
Right.
for the engineers that understand that means from that you can make water, or you can use that for air conditioning, or your heating of the boat, and all sorts of other things on the boat, which means that those systems, and I hate to say it for the suppliers, but those systems potentially will not be required
Yeah.
on the boat, which means you have even more space, right? So
So it's not actually just fueling the boat to go from A to B.
no,
It will change the way a boat physically operates.
yeah. If you integrate and have the ability to use all the possibilities that are there, yeah, you can get rid of so many other systems,
Yeah.
therefore gaining even more space. And potentially that means your boats will look lower. You won't need that extra deck because
Yeah.
you've dropped everything down. You've got rid of all your tanks. You've dropped everything down lower. So the profile of the boat will change, if that's what you want. You know,
Yeah.
it's there's the space gain is probably obviously, and the fuel and everything
Yeah.
else, but
But that's
there's a
really
massive-
interesting that, okay, obviously space is wonderful, and I'm sure every designer would be very happy if they could make more of, you know, the size boat they're building. But actually then it's going to sort of make the whole system more efficient. You know, that for crew, that means their time, maybe they have more time if you're on a boat, you know, with a certain amount of crew. So actually it's potentially going to change the whole way, not just the boat's built and run, but actually then how it operates. So that's something I didn't realize. That's really interesting.
Yeah.
Really interesting. Okay, so Ben, from a build and management perspective, how disruptive is what we're talking about in reality? So if someone comes to you and they want to build a boat powered by nuclear, what does that mean?
I think you've got two bits with all new technology. One will be operational, so the crew, and do we need crew training? What kind of awareness do you need?
Yeah.
And the other one is practicality of fitting one of these things into your vessel. And I suppose this is a question for you guys is, you know, when you look at the operation and side of this, and we've talked about it before, that these boxes are in essence a sealed box.
Yeah.
But my question, I suppose, is can you as a shipyard go and fit that yourself, or do you have to go to a facility that is certified suitable to be able to move that on board and sit it in? Because what we've talked about before is these units you almost, you know, can take out and put back in 20 years later, because as we know, all yachts live forever.
Yeah.
So that refit process. But that's my question: is how do we I don't know, San Lorenzo, Sunseeker, Lursen, Fedship put in one of these themselves, or are we going to have to adapt the facility to enable it?
Yeah, I mean, that's a very good question. That's going to
side of it.
it's going to come down a lot to the regulators. I mean, at the moment we're planning in all of our designs that there's a soft patch that, you know, these units will come in and out of. For our unit, and I think it's similar for some of the other ones coming in the future, is essentially we have 4 pipes coming off the unit. So the unit itself will be stored in a space. The 4 pipes connect to the power generation, which is the turbines and everything else that create the electricity. So you decouple the 4 pipes and you slide the unit out of the unit, or units, right, out the side of the boat. Ideally, it's probably the easiest way. And then you weld it shut and you carry on. Depending on what happens with regulation and IMO, we would obviously like to see that shipyards will be able to install it once we've tested the unit, which is happening right now. Where our unit was fueled up 2 weeks ago. It is currently now sitting at the Idaho National Lab in the US, which is where they test all new nuclear technology. And so we will know a lot more in 6 months. And they're pushing the boundaries. They're testing all the systems. Lloyd's will know a lot more. We'll have a lot more information about it. But ideally, we'd like to see these as a generator where anyone can pretty much pop it in, pop it out. Now that will probably take time for the local ports and the local areas to accept that. And that's where, having all the results from this testing will be a huge benefit, hopefully, if it all goes well. But otherwise, I guess it's up to regulation and Jez and his team.
Yeah, I think so. Almost certainly, definitely, shipyards and shipbuilders are going to need some kind of license or permissioning from a nuclear regulator to handle nuclear material. Goes without saying. To the level at which they're required to do that is yet to be determined. I think a lot of what we're looking at is a sort of proportional graded approach to nuclear. So not the kind of infrastructure and requirements that naval bases require for, say, operation on nuclear submarines. But if it's just a matter of handling and installing something like the Unity battery, then can that be done at a much more sort of proportional level? I think clearly these shipyards are going to need to have processes and procedures in place in the event of certain accidents and scenarios, and the public around that, that's going to be very important. The transparency about the safety and what to do in the event of is key to all of this. But there's conversations ongoing about what that looks like or what might that need to look like. You can talk about it for the Unity battery, but if we want to talk this more holistically about all potential maritime nuclear, then there's a range of different applications and a range of different potential consequences. So the proportionality grows depending on what you're handling. Therefore, shipyards may need differing levels of sort of regulation to handle different applications.
And I guess actually, the wider conversation is not just the builder, but like you've just said then, boats going into port.
Yeah, that's
it's not just going to be a case of, okay, let's train these people and they can pop the module in. There is going to be a shift in all facilities where boats might go are going to need to have regulation. But Jez,
sorry, no, but we've seen that. I mean, and this is to be a positive side of it. We've seen it with like liquid hydrogen, where again, exactly the same principle. Ports needed to be approved. There was nervousness around where you could do it, how you could do it. And then the risk-based approach, working with class, working with the local port authorities, and again, making everyone understand the scenario, the risks involved, means that once ports understand that, then, and you've got that risk assessment in place, then they are open to having you come along in. And that's happened on a number of various ports and is happening all the time. And I think with nuclear, there are already nuclear, let's say, approved ports for everyone, basic wording, but they already exist. So there is a functionality already there that, as with everything new, just takes time as we go through the process and we talk to the different ports and the reality of ports. Monaco is already in discussion about nuclear. So are other areas where they're already foreseeing that this is going to come. So they're now proactively trying to work with the authorities, not just Lloyd's, but, IMO and everybody to adapt to what needs to be done.
That's interesting.
I mean, as you said, it's happening with hydrogen. But years ago, it happened with LNG.
Yeah, exactly.
Yeah.
We've had this process in the maritime industry for a long, long time, and it's just about how quickly we can adapt it.
Yeah.
And
But
adopt
also,
it.
I think the general public are, unless you're in this square of trust, unless you're in that area of knowledge and expertise, of course, you're not going to know all this. So this is why it's interesting to hear this, that we're not just popping up today saying, oh, let's talk about nuclear, we're going to put it on boats. It's been in discussion for years already, the same as any other fuel that has ever been used. Years of research and talking about safety and regulation, because safety is obviously something, and we're going to talk about it a bit later, but all these sort of first ideas, when they come out, of course there's pushback.
Yeah.
And,
Our
and I don't want to
biggest-
sound rude when I say, but and I would be in this category. It comes from not being educated in it. It comes from hearing something from someone or on the news or something, making a judgment without truly understanding the benefits and the precautions. And so already you're years into a conversation that many people don't even know has been had.
And we're talking about new technology now, not the technology that's been in nuclear for the last 50 years.
Yeah.
Don't forget there are currently 700 nuclear units either floating on the water or under the water already in the world.
Right.
They go into port somewhere, and there are only 400 land-based units, and so maritime and nuclear has been around since the 50s, 60s, and a lot has happened.
And the
a lot
technology is
changed,
only
and-
getting safer and better, like everything.
Yeah.
So
Well, and those vessels all use roughly, I think it's as a broad, they're either 20, 25 or 28 megawatt units.
right.
And they're far more enriched in uranium than our unit is. We're 5%, we're called a low enriched uranium. So we're 5% uranium in our units. In theirs, Jez, you'll know better than I do for the Navy stuff. I'm not sure what you're allowed to talk about, but
Really.
it's something up around.
High enriched uranium, mate. We know that.
They're highly enriched in uranium.
Right.
And if you want to create a bomb, you need something like 95% pure.
Right.
And which is why Iran's been struggling to make it.
Yeah.
We talk about them and what's happening, but they've struggled for years to because it's not something you just pick up a bunch of uranium and add it all together and suddenly it's 95%.
Sure. And you've got to have, I
That's-
guess, the technology to create that and the people with the expertise to do it.
Exactly. So, the next thing we have now, we're looking at 1 megawatt units for the yacht industry potentially, and 5 megawatt units maybe for the bigger boats.
Right.
Right. So those are going to be the two that we really have to focus on for the yacht industry, in my opinion. So the harbours, we're going to prove in the next 6 months that ours is safe.
Yeah.
That our 1 mega, so that the other manufacturers will be trying to prove that their 5 megawatt units are safe.
Yeah. But if you're saying 1 megawatt and there's already 700 vessels at sea with potentially 28 megawatt, they all have to go in somewhere.
Yep.
So already there's facilities that are capable of taking vessels with 28 megawatts. So actually what you're doing is not new. It's just your technology will be new to yachting.
Yeah. And also, those units, those big units, when they go into port, their safe zone is around the port is huge.
Right. Because they're 28 megawatt.
Well, the potential for if it went wrong is much bigger.
Of course.
Whereas ours the intention
much
is that
smaller.
our safe zone will be the engine room, the boat, because ours is that small and intrinsically safe. They're also different systems, which Jez might be able to explain better. But one, they're high pressurized systems and they use different technology. We're not. We're low pressure. So, and they have gases in them that can create hydrogen. We don't. We use helium.
Right.
So you never get hydrogen. So Fukushima, the explosion was a little hydrogen explosion because things got hot, gases were released. Chernobyl was all about high pressure systems.
Yeah.
And their pressure was massive, and the temperatures they got up to like 1800
Yeah.
degrees, whereas we only get to 600. We operate at 600, 800, we shut down.
Right.
So all these new systems and technologies have different safeguardings
Yeah.
that are built into the system, and they have to shut down from 100% to zero in 200 seconds.
Wow.
All the new stuff will have to do that. We do that. Everyone else will be the same.
Yeah.
So your safety, once you're at zero, there is, there's a little
no
bit of heat
risk.
still happening, but there's no reactivity. So, it's safe.
Interesting.
So a lot of thought has gone into all the new technology about making it safe, making it so you could have it in your back garden to run the village, or take it to a festival and run the festival. Instead of having diesel generators pumping away in the background.
And that's the secret. I think when you say nuclear, and most people watching this will just think of a big mushroom cloud, but the actual reality is coming. And what these units are, the driving force is land-based. So all these massive server farms, because we all talk to ChatGPT more than we talk to our own spouse, requires huge amounts of power.
Yeah.
So, the big well-known companies are looking at these units to power their server farms. They're looking at them to power smaller villages, or, the ports will start looking at them to power vessels, we've seen it where in an emergency response. So, when you've had a huge hurricane come through and just wipe out an entire Caribbean island, you can bring these on a barge and bring back full power to the island in less than a week.
Yeah.
So it's the pros outweigh the cons, and actually that public perception will change because people will see them more used to seeing them on land.
Of course.
So it's the whole
when it becomes
kind of
more normal
ecosystem is changing.
conversation. Yeah. Thanks for watching this episode so far. We have some great guests coming up, and we wouldn't want you to miss any of those future episodes. So please don't forget to click the subscribe button and enjoy the rest of this episode.
Well, for example, the deployable energy guys have pre-sold 2,500 units for land-based products, and mainly to do with AI. And most of the interest I'm getting talking to shipyards and people is not necessarily to go on the yachts. It's to power the shipyard.
Yeah.
And to give them stable power, because they're draining power from the local villages and towns around them. So, you know, and they're all engineers. They understand how clean and green it is. And obviously by having a 1 megawatt unit, you're reducing the risk.
Yeah, sure. I think that's such an important point that you guys have spoken about, because obviously when we started, we talked about, you know, how most people hear the word nuclear and think scary, but actually when you're talking about new technology, there's so many fail safes in place that actually it's
when you
safe.
Look at the 3 big incidents we've had globally, Chernobyl, Fukushima, and 3 Mile Island, all of those, the reasons and causes for those disasters have been dealt with in the new technology.
Yeah.
Which, you know, and hopefully there's no other thing that they've missed.
Yeah, sure. Right, Jez, I feel like I need to pick your brain. So you've got away with it so far, but here we go. I've got my list. Okay, so what is your involvement with NOxFree, and how long have you been working on the possibilities of nuclear?
So we've been working with Derek and the team for over 3 years now. I joined LR about 3 years ago, specifically to lead the development of the nuclear rules, the requirements we have for LR.
So you joined specifically.
Yeah.
That's interesting.
Yeah. So and we've been working, or I've been working with sort of Derek and the team since I joined. LR had been involved prior to that, and it really is about sort of understanding the requirements of the industry, of the specific project, and what we need to deliver, both from a classification perspective, but also from a statutory maritime and nuclear regulatory sort of vantage point as well, because that regulation just isn't there. You know, civil nuclear is largely based around gigawatt scale nuclear power stations, which are controlled by national governments in countries. So all the rules and regulations have been designed and built up around nuclear being a very strategic sovereign sort of requirement, and everything is based around that. So when we talk about transportable nuclear, especially internationally, there just isn't any sort of rules and regulations to govern that, either in the nuclear or the maritime space. I mean, we will probably come on to the SOLAS Chapter 8 and Code of Safety for Nuclear Merchant Ships, but today there really isn't anything. So it's about understanding, engaging with, you know, the international bodies, the regulatory bodies, to see what and, you know, work with them, tell them what industry needs.
Yeah, because you're right. Because actually, every country has their own rules and regulations for what they use and whatever else. But then when you've got this asset floating around, potentially the world going from country to country, that actually makes it even more challenging. Because...
So there's an interesting distinction between the UN bodies of the IMO and the IAEA in maritime and nuclear specifically, whereas the IMO operates almost like, well, it is a regulatory body. They make statutory requirements which are then passed down to flag states to incorporate international law. The IAEA doesn't do that as a body. What it does is provides guidance on safety and security, but only has a mandate to control safeguarding of nuclear materials.
Right.
So looking after the accountancy and making sure that none of the material is, you know, been able to sort of be siphoned off for, you know, nefarious purposes.
Yeah.
It is their sort of mandate, but security and safety is the responsibility of national nuclear regulators, and therefore has evolved very differently to what sort of statutory maritime and the IMO have done.
Yeah.
So it's about, and we've seen already in the nuclear industry efforts to sort of harmonise some of this regulatory work from like the US and the NRC, the UK's ONR, the Canadian CNSC, and so. But it's very difficult.
Yeah,
it's taken a long time, and they haven't made great.
Probably.
National bodies don't want to accept somebody else's say so that something's safe because of the responsibility and so.
Yeah.
But Jez, I think that is probably, one of the biggest hesitancies of maritime at the moment is, and shipping, because it's not just yachting looking at this. If you've got a container ship that suddenly can go flat out from A to B rather than fuel economy, they're going to make more money quicker.
Mm-hmm.
The issue always is international voyages, isn't it?
Yeah.
And there is a concern, or I believe there's a concern, correct me if I'm wrong, that actually that's probably the biggest challenge at the moment. Is the technology we've seen is coming, and it's coming rapidly. It's how you go from A to B. And in shipping, yes, port A, port B, so that's easier. Yachting changes on the morning because they want to go left instead of right. But it's that international voyage part that is a concern, or is it? Do you think that's changing?
I mean, don't get me wrong. There's a lot of work to be done. The requirements for freedom of international movement, I think, will be a bit of a way off. Liability conventions will be required. There was a Brussels Convention in 1968 that was never fully ratified for nuclear-powered ships. You would need something like that, either revised or something new. But certainly what we can work on to begin with is bilateral agreements between two flag states. So like the UK and the US, you would have seen when President Trump was over, announced the UK-US nuclear corridor. That is a way of sort of getting around that requirement in the short term. And those can grow. Other countries can join. And I think once we demonstrate the technology, which is, I guess, arguably what we're discussing really, then it will be easier for other countries to then sort of join that those agreements. And you either organically grow something like the Brussels Convention, or you have to have a UN body sort of drive the requirement and get people to sign up to it. But we know that getting many international countries to agree on things is somewhat difficult. So I suspect it will probably be something that grows organically. And if I'm honest, I know the point about shipping and nuclear power, I believe, can fundamentally change the very nature of commercial trade. And once countries recognise this and large international organisations start taking advantage of it, then countries will have to come on board. Otherwise, they're going to be
left behind.
You'll be left behind. You'll have to just accept the conventional ships and slower transit speeds, more cost. So I think it will quickly take off.
And this is where we need the adoption, don't we? By all the large shipping companies, containerized companies going cruising along the coast and pulling into all the ports.
Yeah, let's nuclear power in yachting is never going to reach the scales of sort of deployment that I think that the industry would need to see to make it commercially viable. Mm-hmm. But what it is, as I think we've mentioned earlier, is that sort of Formula One, is the sort of the cutting edge of industry, where you can utilize that to demonstrate to industry, to the public, to the international bodies that it is a safe way of operating and powering ships, and therefore support, because we need to have real projects. The regulators are like, nobody's talking to us. Nobody's coming to the nuclear regulators saying, we've got this project. So the nuclear regulators are like, we're hearing a lot of talk about maritime, but nobody's actually said anything to us. So we need to have actual projects that we can present to the nuclear regulators and actually start getting into the detail and working out what needs to be done.
Yeah, because everything is at what you said at the start. It takes one person to do it, and then because actually everything we're talking about is so positive. There's a lot of argument for the fours, and obviously we'll talk a little bit more about the cons, but there's a lot of positivity that could come out of it, like we're talking about for businesses, countries as well, that once the technology becomes more regularly used. I mean, we're talking about yachts specifically today, but in a grander scale, I mean, there's
we're talking to island nations already.
Yeah.
You got a country, and I won't name it, but when they're spending 8% of their GDP on diesel to run the generators on a small island, and then they're held to ransom because of what's going on.
Well, I was going to say,
Middle East, their costs are going up. These small island nations, they want some kind of independence.
But actually, what's going on at the moment in the Middle East is quite a harsh reminder to us everywhere,
Mm-hmm.
that actually we're all a bit sort of held to ransom
Yeah.
for things all, you know, to get product from certain parts of the world. It's affecting the UK. Obviously, there's worse things going on, but we're all affected by what's happening.
Yeah.
So to have alternatives that are regulated, accepted, and I mean, it just a good backup plan, or eventually maybe even overtakes it, that we're not so reliant on certain parts of the world that if there's trouble there, our country then is, you know, sort of shut down economically.
Yeah.
It's
Well,
quite
the CEO of
interesting
Deployable
point.
Energy, when he started this, his whole vision was to make an affordable nuclear plant that basically, you know, anyone with a bit of a million or so could afford, or a town could afford, or a country could afford, or an island could afford.
Yeah.
And if you can walk into an island nation and say, hey, we'll cut your, you know, from 8% GDP down to 3 to 4% of GDP, then all of a sudden that gives them more money. It gives them independence.
Yeah.
It makes them a stronger nation to stand on their own.
Yeah.
You know, and it's
Slightly
incredibly
safer against world disasters. Just on, obviously we're talking, I mean, I agree with everything you say, but just nipping back to the yachting part. So cost wise, is a sort of positive sales point. So I can't even imagine what a module would cost to put on a yacht. Well, we will in a second. But what I'm interested in is, so say for instance, you could say to an owner, we're going to build this 100-meter boat and we're going to put this module on, but it's going to be X amount of money, and you can go over that in a second. Is there quite a good argument that the return on that investment would be quite obvious quite quickly, because you're not potentially having all the other systems and you're not having fuel and things? Because obviously the cost of fuel at the moment is through the roof, and most people who own the boats that we all work with are probably not that affected. But if you could say to them, well, it's X amount, but in 5 years you'll have got that back anyway. I mean, what is the reality of that?
Well, we did a rough calculation, and we think that you pay off the unit in 3 to 4 years.
Really? That's oh gosh, that's
it's a single digit millions, right? So it's not 20 million or 10 million. It's around 9.5 million at the moment. And
that's
in time,
just for the module. So that's not potentially what you're saving on all the other systems.
No. So you're saving on the shipyard, saving on not having to build the fuel tanks. All that costs money. You're not having to install exhaust systems, scrubbers, fuel separators, extra steel for ducts going up through the boat, and all that. Plus, you know, generally speaking, you know, the amount of fuel that the engines use, a rough every 600 hours you change the filters, do your servicing, everything else. You're looking at a 3 to 4 year payoff.
Wow.
So especially for a boat that's moving a lot, if you're just going to sit in the marina and do nothing,
sure.
then that becomes a different calculation. And in actual fact, we did this calculation before the war in Iran. So with the cost of fuel where it is now, well, your payoff is even shorter, especially if it stays up there. So we're not talking about a big figure. It's, you know, when you look at the scheme of the boat, it's, you know, you do a deal with your shipyard and you say, hey, I want to buy nuclear instead of diesel engine. And look at the cost of a diesel engine.
Yeah.
That's not cheap. You know, there are hundreds of thousands plus all the infrastructure that goes with it. It becomes a big number. And more importantly, obviously, it's green. i.e. we're not putting noxious gases into the air, and we're not polluting the planet.
Yeah, so for potential owners looking to build boats in the future, not only do you have that positive sales point of actually you can recoup your money, but actually to be sustainable in a genuine way. And that word gets used so much in our industry, and it's an interesting term, but actually to be able to say that, you know, you can run the boat in a green way is unusual. So.
And not plan stops for refueling. And as Ben said, you can cruise across the Atlantic, and if the weather's nice, well, let's just do 18, 19 knots today. You know, because we can. And let's get there quicker.
And also, I guess if you've got an owner that's quite adventurous, I mean, ultimately, as long as regulations cleared to go in certain countries and things, you can really...
Well, nuclear is clear to go already to Antarctica and Arctic, isn't it? Because that's what they're using.
Yeah.
That's where all the icebreakers are.
Yeah.
And they've been going there forever. So, you know, there is that option.
Yeah.
And then you'll have...
another interesting sort of sales point. I'm just thinking sort of how, you know, when you come to talk to owners in the future, all these facts and sort of points that I obviously wouldn't think of, but actually all the positives of it really are realistic
Yeah.
and are probably going to be very important to future owners
And
when
it's,
they're building.
for example, the fjords in Norway are banning fossil fuels to
Yeah.
some of the fjords. Well, a cruise ship could just chuck a couple of containers on the roof for the week,
Yeah.
or
Yeah.
put these in instead. And those special zones will become bigger. There'll be more and more of them,
Yeah.
I think, in the world as time goes on, because we're going to have to try and cut down all the.
You mean special zones where they're going to ban fuel? Yeah,
Yeah.
no, agreed. I think there's already places thinking.
And not only that, it doesn't make any noise.
So no noise pollution
No.
either.
So your turbines make a bit of noise, but your actual power generation, your power unit, the core, doesn't make any noise.
Yeah.
It's quiet. So there's a lot of benefits. And then you come to, there's everyone's going to go, well, what about end of life? Where are you dumping all this? Well, on our unit, 65% of it is calculated to be reused.
Oh, really?
So you get that and you mix it in with some other new 5% enriched uranium and you put it into the next unit. And then the rest is held aside for smaller units that they're planning to build. And then they think at the moment there might be 5% of it that they'll have to store just for future technology.
And how big is that 5%?
It's about the size of a cup.
Yeah.
It's a mug size.
Interesting.
So,
Because that's
it's
something actually I was thinking of earlier, because again, from the general public's point of view, what happens when it's finished?
And we're calculating the actual core, which is like a heat exchanger. This is 500 high in diameter. It's about this size in diameter, and that they calculate that will be able to be reused 5 times before they have to take it apart and then probably repurpose its metal. So
yeah. But the maintenance of it again is not comparable to an engine.
No.
Jez, I'm going back to you. Sorry. What, in your opinion, is the biggest barrier right now? Because we've talked a bit about regulation. Is it regulation? Is it the technology? Or is it perception from boat builders, owners, or general public, or the powers that say yes or no to these things?
It's an interesting question. It's one that I'm asked all the time. I dare say it depends on how you want to look at it as to potentially the answer. I personally think that industry and public perception is probably the biggest challenge that we have, the biggest barrier. And it's where we need to obviously spend a lot of time and effort in clearly, articulating what's being done, having that transparency about the process, and re-educating or educating at an earlier age the public, because there's a lot of misconceptions and a lot of fake news and misinformation around nuclear and the potential effects and what it can and can't do and so on. So that is, I think, is probably the biggest challenge. Don't get me wrong, there is a lot of work to be done in the field of regulation and international regulations and conventions, as we discussed earlier, but that's a process. And there's a lot of work to be done on the technologies. And again, but that's an engineering process. It's never been about, can we put nuclear onto a yacht or onto a ship? We've been doing that, as Ben said, since the 50s, 60s, and every decade since, largely in defense capacities. It's never been about, can we do it? The question is, can we get these new technologies to a place they need to be at to operate safely and compliantly in the way that people are suggesting they can? And most importantly, can it be done economically? Because if we can't find a way of producing the technology, licensing the technology, operating the technology at the right cost, then it doesn't matter how good it is, how green it is. Nobody will use it. They'll just use a cheaper alternative. So perception, industry and the public is, I think, really important. But also we need to define a collective pathway that enables us to make this economically viable. Because if that can't be done, then nothing else really matters.
I suppose also it's a bit of 6 of one, half a dozen of the other, isn't it? Because like you say, the technology is coming fast, like we said earlier. Already there is technology that exists that allows nuclear to be on vessels, because like you said, it's been there for decades. You can't get the regulation without having the products and working out how they're going to work. And you can't change public perception until you can prove really in real life that it's going to work and it's safe. So I guess it's just got to come, hasn't it? You got to get the right technology, get a person to believe in it and put it on their boat, work with Lloyd's registry and all the flag states and the builders and all pulling in the same direction to then launch it and prove that it is
I mean,
the right sort of thing to push forward with.
There's definitely a lot that can be done now. The technology and the qualification of the technologies is, from my position, something that's going to happen independently, that needs to happen independently.
Yeah.
Deployable, Bobby's out there with his team demonstrating that, in critical testing, it responds and reacts the way that they've said this, the modeling says that it should. They're going to demonstrate that it shuts down, that it's passively safe. It's, and that should allow us to get to a place where that the Unity battery can be like part licensed, if you will, because ultimately we need to get to a place where nuclear power units are like a commodity, no different to gas turbines. That these developers, vendors can, design, build, manufacture, and then sell these products, and that yacht builders, yacht designers can say, look, this is the design of the yacht we want. This is the power that we want it to have. This is the space that we've designed for which product is available for us. That's what we want. And then it's a case of integrating that product into the application. And that's the solution that we've developed at Lloyd's Register, is how do we integrate the nuclear into the maritime environment? So if we can get the nuclear product, which will have to happen, because if that doesn't happen, then this whole conversation is moot to begin with. So the assumption is that does happen.
It's coming.
Yeah, so that happens. The question then is, how do we bring the worlds of nuclear and maritime together in a way that allows us to achieve the kind of assurance and regulation that we need? One, to be able to get a nuclear license to operate and meet statutory and class requirements, but also to show to the public and to insurers and port authorities and port states that it's safe. And there's the whole life cycle approach. Derek mentioned decommissioning and disposal. You won't be able to get a license unless you've got a clear financed path for decommissioning and disposal. So the whole life cycle approach has been taken into consideration in the framework that we've developed. There's a lot of work to do. We know that we need to talk to the national nuclear regulators, because we need them to license in a very different way to the way that they're currently licensing. Everything is site license based at the minute. So you identify a site, you demonstrate the site is safe and sufficient to have a nuclear reactor, and then you license the whole facility installation. Whereas we want to take a nuclear power unit as a part licensed and then integrate and then license that application. So it's a bit of a philosophy change for the nuclear industry, but also for the maritime industry, because you're going to have a safety case for these applications. The licensee, I should clarify, the licensee will need a safety case to get the license to operate. The question is who the licensee is going to be. It could be the yacht owner. It could be it could be deployable energy. They might want to be the licensee, and they might want to rent the Unity battery to the end user and say, look, pay this much per year over the life cycle, and then we will take it away. You don't have any of that responsibility to deal with any of that. We'll just take it away. We'll refurb and manage all of that stuff, and then we'll just give you another one. It's that sort of battery mentality that people talk about. But these are all under discussion. We need to understand what these models look like, what the considerations are, how we designate the sort of responsibility and accountability for certain actions and safeguards within that. It's not that dissimilar to how UK defence submarine application works. It just, again, needs to be proportional and affordable for it to work longer term.
Because surely when nuclear was put on commercial vessels in military, you would have had, not you obviously because you weren't alive then, but whoever first put something onto a boat would have had to go through all of this to build guidelines and rules and regulations. So it's been done before, but just for a different type of vessel.
Yeah, well, I think defence and is a very different way of approaching it. The defence application is very analogous to the civil licensing requirements. So in the UK, they have the same. So in civil, you have the licensing conditions. In defence, you have authorising conditions, and they're a mirror of each other. And then you have a few additional ones to compensate for the transportable nature of submarines. but there's a lot of assurance and a lot of certification, verification, and a lot of processes, checks and balances, as you would expect there to be.
Yeah.
But bearing in mind, this is a highly enriched pressurized water reactor. So the consequences are different to what we're talking about.
Mm-hmm.
Therefore, we believe the regulatory requirements should be proportional to the risk. You know, when the vendors demonstrate the safety and the nature of the technology, then that will define the kind of safety case you need to develop to provide the levels of assurance. We expect that to be a lot smaller than what the defense application is. And depending on how the industry stands up as well around it, depends whether we need to have specialized yards or specialized ports to accommodate this, or whether we can just provide a far lower level of regulatory assurance to commercial ports to be able to accept nuclear powered assets in, because we already transit and sail high level nuclear waste on ships already. So I don't think it's a big step. Again, there's a lot of work to be done, and we need to understand what the risks are, and that can only be informed by the output from the vendors and the testing and what their requirements are. But we need to engage with the regulators now, with the industry bodies now, to start that process, start the conversations about how can we approach this, what do we need to do, what level is considered safe, you know, where do we need to get to? Because again, nuclear and maritime operate on a completely different philosophy, whereas, you know, the maritime industry traditionally has prescriptive rules. So we say this is a level you must achieve, and then everybody achieves it. Whereas nuclear works on the alert principle of as low as reasonably practicable. So if you can make it safer, then you should make it safer, is the expectation. Where that line is drawn is a little bit grey, which is what we've seen in the recent Fingleton reports of the UK government, which says that they've been overly conservative in their application of the alert principle. Because it's very easy to just err on the side of caution.
Sure.
But I think if we're going to overcome global challenges like global warming and climate change, and states and flag states want to have energy independence, energy security from fuel volatility that we see for things like the Middle East conflict, or dare I say it, even potentially hydrogen and ammonia production, because there are going to be industries that are prepared to pay more than the maritime industry are for those fuels. So it's not always going to be a cert that if you have an ammonia or a hydrogen powered vessel that the fuel is going to be as available as people might think it is, because it's not easy to produce. It's going to be expensive to produce as well. But if you've got a nuclear powered unit on your asset, then you've got that assurance that for that operating cycle, you know how long you got fuel for, how much it's going to cost, and it provides that sort of stability and assurance that I think owners want moving forward.
And if they're investing a lot of money into building a boat with that technology, they're going to want that, aren't they? I hope you've enjoyed the first part of this podcast. Join us for part 2, which will be released soon.